Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video lecture, I am going to discuss about the different types of DC generator. So in previous session, we are discussed about the series wound DC generator and shunt wound DC generator. Now in today's class, we are going to discuss about the compound wound DC generator and separately excited DC generator. Okay, so the types of DC generators, the first one is the self-excited DC generator and second one is the separately excited DC generator. So in this self-excited DC generator, we are already completed first two. So that is series wound DC generator and second one is shunt wound DC generator. Now this is third type, that is compound wound DC generator, right? So this compound wound DC generator, which is classified into two types. So first one is short shunt compound wound DC generator and second one is long shunt compound wound DC generator. Okay, so now we'll discuss these two. Okay, so first one, short shunt compound DC generator. So here in this short shunt compound wound DC generator, so having the we are having the armature resistance, series field and shunt field winding. Okay, so here, so first we need to draw the diagram here. Series field and armature, and here is the generator, and here is shunt field winding, and these all are connected to the load. So load is RL. Now here is the generator. So for this generator, we are having the generated EMF or generated voltage, that is EG. And for this resistance, we are having the armature resistance RA, and here we are having the series field resistance. For the series field winding, we are having the series field resistance, and for the shunt winding, we are having the shunt field resistance, that is RSH. Okay, so load is there. Across this load, we are having the terminal voltage. Let us take as VT. So terminal voltage is VT, right? So now for this short shunt compound DC generator, we need to give the current directions, right? So here through the armature resistance, I am taking current as IA, armature current IA. Now at this node point, so this is node point, at this node point current is dividing. So current through this RSH I am taking as ISH, and current through RSC I am taking as ISC, right? So current through RSC is ISC and current through RL is IL. And across this load we are having the terminal voltage, let us take as VT. Okay, so this diagram belongs to short shunt compound DC generator, right? Now for this short shunt compound wound DC generator also, we need to write the current relations, voltage relation and power relation. So these three things we have to write. So current, voltage and power. So now first current relation. So current relations of short shunt compound wound DC generator. So here RSC is there. So this RSC and load, so these two are connected in series. So in series, the what is the constant term here? Current is constant. So current through RSC, that is ISC, equal to current through load IL. Okay, so current through RSC, that is ISC, is equal to IL. And now apply KCL at this node point. So KCL states that the algebraic sum of the incoming current is equal to the algebraic sum of the outgoing currents. So at this node point, incoming current IA equal to the algebraic sum of the outgoing current, that is ISH plus ISC, or IA equal to ISH plus IL. Okay, so here is the current relations. So the current relations are ISC equal to IL, and the second current relation is IA equal to ISH plus ISC, or IA equal to ISH plus IL, right? Now we have to find out the shunt field current, that is ISH. We need to calculate the ISH. So here all are connected in parallel. In parallel, voltage is constant. So voltage drop in this branch is equal to voltage drop in this branch. Okay, so voltage drop in this branch is equal to voltage drop in this branch, right? So now voltage drop in this branch, that is RSH, ISH RSH is equal to voltage in this branch, that is ISH and RSH is equal to VT. So voltage in this branch, that is VT plus ISC RSC. Okay, so voltage in this branch is equal to, and voltage in this branch, that is ISH RSH is equal to VT plus ISC RSC. Then ISH equal to VT plus ISC RSC divided by RSH. Here is the another current relation of given short shunt compound DC generator. Okay, here is the current relations, ISC equal to IL, and next current relation is IA equal to ISH plus ISC, or IA equal to ISH plus IL, and another current relation is ISH equal to VT plus ISC RSC divided by RSH, right? So these are the total current relations of the short shunt compound DC generator, right? Now we have to write the voltage relations. So the voltage relation, for the voltage relation we have to apply KVL in this first loop or in this second loop. So obviously load is this side, so we need to apply the KVL in this second loop. Okay, so here is plus and here is minus. Now in this case I am starting from this point. So when I am starting from this point, always we need to take the second polarity. So here plus EG and voltage drop across this armature resistance minus IARA minus here ISC RSC minus voltage drop across this load is VT or ILRL. So minus VT equal to 0. Then EG equal to VT plus IARA plus ISC RSC. Again we can also write brush voltage drop, that is VB. So two brushes are there, then VB is equal to 2. Here is the voltage relation of the given short shunt compound DC generator. So EG equal to VT plus IARA plus ISC RSC means series voltage drop plus VB brush voltage drop. Okay, here is the voltage relation. And next one is power relation, right? So power through the generator or power developed by this generator PG is equal to EG into IA. Power developed by the generator is EG into IA, and power from the load is equal to Vt into IL. So this is the power relations of the given short shunt compound DC generator. Okay, so these are the current relations. Here is the voltage relation, and here is the power relation of the short shunt compound wound DC generator. Okay, so this is about the short shunt compound DC generator, right? And in compound wound DC generator, we are having the second type, that is long shunt compound wound DC generator. So here, so in this long shunt compound wound DC generator, so very simple. So previously we have discussed about the short shunt compound generator. For the long shunt compound wound generator, we can remove this connection from here to, and we can place here. Then the diagram is belongs to long shunt compound wound DC generator. Okay, remove the connection at this point to and connect here. Then the diagram is belongs to long shunt compound wound DC generator. Okay, so here, so we need to draw the diagram here. So here is the generator. Shunt field winding, and this is load. So this is generator. For this generator, we are having the generated EMF, and this is armature resistance, and this is for the series field winding, we are having the series field resistance. So these two are connected in series, and we are having the shunt field winding. For the shunt field winding, having this amount of resistance, that is represented as a RSH, and this is load RL. Now across this load, we are having the terminal voltage VT, right? Now for this long shunt compound wound DC generator, so we have to give the current directions, right? So from this EG, so current through this armature resistance, I am taking as IA. IA is nothing but armature current, and current through RSC, I am taking as ISC, that is series field current. Now these two currents towards this point, from this point current is dividing. Okay, if the current is dividing means these all are connected in parallel. So current through load, I am taking as IL, current through RSH, I am taking as ISH, right? So here, now for this long shunt compound wound DC generator, so now we need to write the again current, voltage and power relations of long shunt compound DC generator. Okay, so now first we need to write the current relations. So the current relations of long shunt compound wound DC generator is, so here armature and series field resistance, so these two are connected in series. In series current is constant, then IA is equal to ISC, IA equal to ISC, because current is same only. Now apply KCL here, so incoming current is equal to the algebraic sum of the outgoing currents, that is ISH plus IL. So IA or ISC equal to ISH plus IL, right? So now we need to write the shunt current, that is ISH. So here is the parallel branch, and this is also parallel branch, and this is also parallel branch. So in this parallel, voltage is constant, so that VT is constant. Then ISH is equal to VT divided by RSH. ISH is equal to VT divided by RSH, right? So here is the current relations. Now voltage relation. So the voltage relation of long shunt compound wound DC generator is, we need to apply the KVL here. We need to apply KVL in this loop. So for that, I am starting from this point. So when I am starting from this point, always we need to take the second polarity. So plus minus, we need to take the second polarity, that is plus EG minus IARA minus ISC minus VT equal to 0. So here I am starting from here, plus EG minus IARA minus ISC minus VT or minus ILRL, that is equal to 0. Now simplify this equation, we'll get EG equal to VT plus IA into, so IA and ISC both are same, so that's why I'm taking as a IA as a common term. So IA into RA plus RSC plus brush voltage drop VB. So here we are having the two brushes, then VB is equal to 2. So voltage relation. Now the power relations. So power relations of the generator. So power developed by the generator, that is PG equal to EG into IA or EG into ISC. This is power developed by the DC generator, PG equal to EG into IA or EG into ISC. And power from the load, that is equal to again VT into IL or IL square into RL or VT square divided by RL. So we can take any equation, right? So these are the current relations, voltage relation and power relation of the long shunt compound DC generator. Okay, so these two are belongs to compound wound DC generator. Okay, now the second type we are having the separately excited DC generator. So for this DC generator, it is excited by the separate DC supply. So here is the diagram. We need to give the separate DC supply. So here is the generator and armature resistance, and it is connected to the load. So generator, and this is EG, and this is RA, and this is RL. Across the load we are having VT, terminal voltage is VT, and current through RA is IA, current through RL is IL, right? So now here also for the separately excited DC generator also we need to write the current, voltage and power relations. So current relation, so IA is same as IL. So because RA and RL, these two are connected in series, then currents are constant. So the total current is same as IA and IL. So IA equal to IA, that is equal to IL. So current relation. Now the voltage relation, we need to apply the KVL in this loop. So this is plus and minus. So apply KVL. So plus EG minus IARA minus VT equal to 0. So plus EG minus IARA minus VT or minus ILRL equal to 0. Now EG equal to VT plus IARA plus brush voltage drop VB. Here is the voltage relation of the separately excited DC generator. Now power relation. So power from the generator is equal to EG into IA or EG into IL is the power relation of the separately excited DC generator, and power from the load is equal to VT into IL. Okay, So here is the current, voltage and power relations of the separately excited DC generator. Okay, so these are the different types of the DC generators, right? Now we'll discuss the problems on this. So here this problem is based on the long shunt compound DC generator. Okay, so the problem is belongs to long shunt compound generator. So here the question is, a long shunt compound generator delivers a load current of 50 amperes at a 500 volts, means at a terminal voltage of the 500 volt, and it has armature, series field and shunt field resistances of 0.05 ohm, 0.03 ohm and 250 ohm respectively. Now we need to calculate the generated voltage and armature current. So allow 1 volt per brush for contact drop. So brush voltage drop for one brush, it will give 1 volt. So 2 brushes are there, then VB is equal to 1 plus 1, that is equal to 2. Okay. So before that, first we have to write the given data. So here a long shunt compound generator delivers load current, that is IL, equal to 50 ampere at a terminal voltage. Vt is equal to 500 volts and has armature, that is Ra, armature resistance is 0.05 ohm and series field resistance is 0.03 ohm and shunt field resistance is 250 ohm respectively. Now we need to calculate the generated voltage Eg and armature current Ia. So then Vb is equal to, they are given 1 volt per brush, that is equal to 2, right? So here for this long shunt compound wound DC generator, so we are having the equation. So Eg equal to Vt plus Ia into Ra plus Rac plus Vb is the equation, right? So here, so before that, first we have to calculate the armature current Ia. So here armature current Ia equal to ISH plus IL. Already we know IL value, that is 50 amperes. Now we need to calculate the ISH, where ISH, that is shunt current ISH, is equal to Vt divided by RSH. Shunt current ISH is equal to Vt by RSH, that is equal to, what is Vt? 500 divided by RSH 250, that is equal to 2 amperes. Now substitute IL value and ISH value in this armature current equation. We will get Ia equal to ISH 2 plus IL 50. So then armature current Ia equal to 52 amperes is the armature current. Now we need to calculate the generated voltage, that is Eg. So the generated voltage Eg equal to Vt plus Ia into Ra plus Rac plus Vb is the equation. Now, so Vt is 500 plus Ia is 52 and Ra 0.05 plus Rac 0.03 plus Vb is 2. Now by calculating this equation, we will get 506.16 volts. This is the generated voltage of the given long shunt compound DC generator. Okay, here is the calculation part of long shunt compound DC generator, right? So we'll go for the next problem. So here in this second problem, it is belongs to short shunt compound DC generator. So in this short shunt compound wound DC generator, so here they are given the load current. So load current of 30 amperes, load current of 30 amperes at 220 volt, and has armature, series field and shunt field resistances of 0.05 ohm and 0.30 and 200 ohm respectively. So here we need to calculate the induced EMF and the armature current, and which will allows 1 volt per brush for the contact drop. So here in this problem also we need to calculate the generated EMF. So here for the short shunt compound generator, so the generator equation is Eg equal to Vt plus IaRa plus Isc Rsc plus Vb is the equation, right? So here, so now first of all write the given data. So a short shunt compound generator delivers a load current. So load current IL equal to 30 amperes at a terminal voltage Vt equal to 220 volts, which has armature resistance, that is Ra equal to 0.05 ohm, and Rsc series field resistance 0.30 ohm, and shunt field resistance Rsh is equal to 200 ohm respectively. Now we need to calculate the induced EMF or generated EMF of given short shunt compound DC generator, and also we need to calculate the armature current Ia, and Vb is 2. So 1 plus 1, that is equal to 2 volts, right? So here we need to calculate the armature current first. So in this circuit, this is armature current and this is IL and this is Isc and here is Ish. So now armature current Ia is equal to Ish plus IL. Okay, so IL they are already given 30 amperes. Now we need to calculate the Ish, where Ish equal to Vt plus Isc Rsc divided by Rsh is the Ish value. That is equal to, so Vt, what is Vt here? 220 volts plus Isc. So here Isc value, what is Isc? Isc is nothing but Isc or IL value is 30 amperes plus Isc is 30 into Rsc is 0.30 divided by Rsh is 200. Then the shunt current Ish is equal to 1.145 amperes is the shunt current value. So by calculating this equation, we will get the Ish is equal to 1.145 amperes. Now we have to calculate the armature current, that is Ia equal to Ish 1.145 plus IL 30. Then Ia equal to 31.145 amperes is the armature current, right? Now we need to calculate the induced EMF or generated EMF of given short shunt compound DC generator. Okay, so here now we need to calculate the Eg value. So here for this short shunt compound DC generator, so Eg equal to Vt plus Ia Ra plus Isc Rsc plus Vb is the equation. That equal to, what is Vt? Terminal voltage is 220 plus armature current Ia 31.145 into armature resistance is 0.05 plus Isc. What is Isc? 30 into Resc 0.30 plus 2. Now by solving this entire equation, we'll get Eg as 232.56 volts is the induced EMF or a generated voltage of the given short shunt compound DC generator. Okay, here is the some problems on the different types of the DC generator. Okay, so thank you one and all.